In this lesson, we are going to learn normal distribution, and we'll also look at its special case, that is standard normal. So the notation is x follows normal mu and sigma square. So this is the mean and this is variance. Okay. So the PDF of normal distribution is 1 over sigma square root 2 pi a to the power minus 1 over 2 times x minus mu whole divided by sigma whole square, and the range of x is minus infinity to plus infinity. All right, so this is the PDF. Now let's look at the shape of normal distribution. So the shape is called Bell shape. Okay, and this is the mean, median, or mode. So in normal distribution, mean is equals to mode is equals to median. All right, and this is mu. So this is mu. The two halves of the normal distribution are equal. All right. Now there is something called 6 sigma rule in normal distribution. So if we move the sigma from mu, so let's say this is sigma, so suppose this is mu plus sigma, then this area is actually approximately 34%. And if we move again sigma, so let's say this is mu plus 2 sigma, then this area is 14% approximately. Okay, and if we move one more sigma, say this is mu plus 3 sigma, then this area is approximately 2%. Okay, and similarly in the left side, if you move minus sigma, then this is mu minus sigma, this area is 34%, and mu minus 2 sigma, this is 14%, and then mu minus 3 sigma, this is 2%. So this is called 6 sigma rule. All right, now this is sometimes very useful. So we can write this in the probability form. Probability x is less than mu, this is 50% area, right? Or probability x is greater than mu, this is also 50%. And probability x is greater than mu but less than mu plus sigma, so you can see this is mu and mu plus sigma, so this is 34% approximately. So I can say this is approximately 0.34. And probability x is greater than mu minus sigma less than mu plus sigma, this is approximately 68%. All right, now probability mu minus 2 sigma greater less than mu plus 2 sigma, this is approximately 0.96. okay, so this is sometimes very useful, so it will be helpful for you to solve some questions. Now let's see what happens to the graph when we change mean by keeping the variance constant. So different mean but same variance. So suppose x follows normal 50, 100 and y follows normal let's say 30 comma 100, or let's keep the variable constant. We are basically changing the values. So x follows normal 60 comma 100. So how the graph will change? So let me draw this. Okay, so by changing the mean, the graph will shift either to the left or right, but the shape of the graph will not change. Okay, because the variance is constant. So suppose this is 50, the mean is 50, then if we increase the mean by 10, that is 60, then the graph will shift to the right. So something like this. Okay, although the graph is not that good, but you can understand the concept. So if you move minus 20, then the graph will shift to the left. This is 30. Okay, so by keeping the variance constant, the graph will not change the shape, it will only change its position. Now what happens if we change the variance keeping the mean constant? So say x follows normal 50 comma 100, x follows normal 50 comma 120, x follows normal 50 comma 80. So in this case, shape will change, but the position will be fixed. So suppose this is the graph. Okay, then as we increase the variance, the curve will start become flatter and flatter. Okay, so suppose this is 50 and the variance is 100. So the variance is 100, then if we increase the variance to 120, then this will become more flatter. Okay, let me draw this again. All right, so this is again 50, the mean is 50, but the variance is 120. And if we decrease the variance, then this will become narrower. Okay, so the graph will be something like this for the variance 80. All right, so this is how the position and the shape changes by changing the mean and the variance of normal distribution. Now how do we calculate the probabilities in normal distribution? So for example, if this is x less than 2.5, so what is the probability? So to calculate such probabilities, we basically convert the normal distribution into a standard normal distribution, and this is when the standard normal comes into the picture. So let's study standard normal and then we'll see how we can calculate the probabilities. So standard normal, and this is the special case of normal distribution. Generally we use z symbol to denote the standard normal. So z follows normal 0 comma 1. So this is the mean and this is the variance. Okay, so you can see in the normal distribution the mean and variance can be anything, but in a standard normal the mean is 0 and the variance is 1. That's fixed. That's why we call this standard normal. And we saw that the PDF of normal distribution is 1 over sigma square root 2 pi a to the power half times x minus mu divided by sigma whole square. So if you put mu equals to 0 and sigma equals to 1, then you'll get the PDF of a standard normal. So this becomes 1. So this is square root 2 pi a to the power half, and now we replace x with z, and mu is 0, sigma is 1, so this is square. So we can say the PDF of standard normal is 1 over square root 2 pi a to the power half z square. Okay, and the range of z is infinity, less than infinity but greater than minus infinity. Okay, so this is the PDF of standard normal. And now let's look at the graph. So again, the graph is the bell shape because this is standard normal, you know, this is again normal distribution. This is only the special case. So suppose this is the graph. So the Six Sigma rule still applies in the standard normal. So the mean is 0, and if you move the 1 unit in the right side, then you'll get 34% area, and 1 more unit on the right side, this is 14%, and 1 more unit on the right side, this is 2%. And similarly on the left side, if you move -1, this is 34%, -2, this is 14%, and -3, this is 2%. Okay, so Six Sigma rule still applies in the standard normal. So now we can say that the probability z less than 0 is 0.5, and probability greater than 0 is also 0.5. All right. One more thing that you can note from the graph is, let's say this point is A. Now forget this area now, this point, forget this thing now. So suppose this is A and this is the region, and this is, okay, so this is minus A, this is A, and this region. So can I say that probability z is less than minus A is same as saying probability z is greater than or equal to A? Do you agree with this? Because in normal distribution, the area on the left side and the area on the right side is basically the same, right? So this area is same as this area. Okay, so we can write this. Similarly, we can say probability z is greater than or equal to minus A. It's same as saying probability z is less than or equal to A. Okay, so we'll use this property while solving the question. And to calculate the probabilities, we'll never use the integration. We'll basically look at the values from table. All right, so we use table to look at the values. We'll never use integration, and that's why we use this property, because in the table you are only given the value for less than, equal to, and for the positive values. Okay, so this property will help you to change the negative values to positive. So in the table, the value is only given for less than or equal to and for positive values. So this value is only given in the table. And priority always goes to correction of value first from negative to positive, and then we change the inequality sign. All right, so first we change the sign from negative to positive, and then we change the inequality sign. All right, so this is the order. First we prefer to change the sign from negative to positive, and then we change the inequality sign. Now let's look at one example. So say probability z is greater than -2 but less than 1.5. So we know how to break this. Probability z is less than 1.5 minus probability z is less than or equal to -2. Now as I told you, in the table value is given for this sign, less than or equal to sign, and for the positive values only. Okay, so let's look at these values in the table, and we need to change this value because this is negative. So let's do one more step. Probability z is less than 1.5 minus probability z is less than or equal to 2. Now again we need to change this inequality. So one more step, probability z is less than 1.5 minus 1 minus probability z is less than 2, right? So now let's look at the values from the table. So this is the table of a standard normal distribution, and this is only applicable for probability z is less than or equal to z. All right, now we are looking for the value x equals to 1.5 and x equals to 2. So this is the probability and this is the x value. So let's look for 1.5. So here you can see this is 1.5 and this is the probability. So 0.93319, and x equals to 2. Here you can see x equals to 2 and this is the probability. So 0.97725. So now we can say this is 0.93319 and this is 1 minus 0.97725. So if you solve this, you'll get 0.91044. So this is the answer to this question. All right. So this is the example of a standard normal distribution. But how do we calculate the probability of normal distribution? So before that, let's look at how we convert normal into a standard normal. So this is called standardizing. So standardizing, that is converting normal into a standard normal. So x follows normal mu sigma square, and z is equals to, if you substitute z equals to x minus mean divided by the square root of variance, then this follow standard normal, that is 0, 1. Okay, so this is how we can convert the normal into a standard normal. Whatever is the random variable, you simply subtract mean from that and then divide with the square root of variance. All right, so let's look at one example. Say x follows normal 5, 100, then z equals to x minus 5 divided by square root 100, which is x minus 5 divided by 10, follows standard normal 0, 1. Now let's see how we can use this conversion to calculate the probability. So suppose you are given to calculate the probability x is less than 7 and this is normal distribution. So you can convert x into a standard normal by subtracting the mean and dividing with the variance, square root of variance. So this is x minus mean is 5, dividing it with the variance, that is square root of variance is 10, and we need to do the similar calculation on the right side. So this is 7 minus 5 divided by 10, and this whole thing is basically z. So z less than 0.2. Okay, now we can look at this value from the table, and the answer is 0.57926. You can check this value from the table. All right, now let's see one more example. Suppose you are given probability x is greater than 1, then we can change this x minus 5 divided by 10. This is greater than 1 minus 5 divided by 10. So this thing is z greater than minus 0.4. And now remember, we need to change the sign first. So probability z is less than 0.4. And now you can see, sorry, this is z. Now you can see the inequality sign is, it's the less than, right? So we don't need to change it anymore. And if you look at the value from the table, you'll get 0.65542. All right, so this is how you can calculate the probabilities of normal and standard normal. Now there is one more normal distribution, that is log normal. So let's look at that. So log normal distribution. The notation is x follows log normal mu sigma square. Now here this is not mean and this is not variance. All right, this is not the case in log normal. Log normal is slightly different, and the PDF of the log normal is 1 over sigma square root 2 pi 1 over x times e to the power half log x minus mu divided by sigma whole square. Okay, so you can note the difference between the normal and the log normal. In log normal we have extra term, that is 1 over x, and in place of x we have log x, right? So this is different, and one major difference in these two different distribution is the range of x. In the normal distribution the range is basically minus infinity to plus infinity, but in log normal the range of x is greater than 0. So this is one major difference. All right, and the graph of the log normal is also different. So let's see. So this is the graph of log normal. You can see this is called the tail of the graph. So the tail is on the right side, that's why we call this positively skewed graph. So this is the graph of the log normal distribution. Now how do we transform the log normal into normal distribution? So let's look at that. So the PDF of log normal is 1 over sigma square root 2 pi 1 over x times e to the power minus half log x minus mu divided by sigma whole square, right? And if we integrate this in the whole range, that is from 0 to infinity, then we'll get the integration 1, because this is the PDF of log normal, right? And this is the property of the PDF. Now let's substitute y equals to log x, and we also need to change the limit as well as dx. So let's differentiate this. Dy equals to 1 over x dx. Now in place of 1 over x dx we can substitute dy, and if we put x equals to 0, then we'll get y equals to minus infinity, and if x equals to infinity, then y equals to infinity, right? So the limits are minus infinity to plus infinity. This constant will remain as it is. 1 over x dx is dy, so this is dy e to the power half. In place of log x we can write y minus mu divided by sigma whole square, and this is equals to 1. So you can see this whole term is basically the PDF of normal distribution, right? So this is how we can convert log normal into normal, and this is the substitution, y equals to log x. All right, now let's look at the mean and variance of log normal. So mean, that is expectation of x, is e to the power mu plus half sigma square. So this is in power, and the variance Vx is e to the power 2 mu plus sigma square. This is in the power, and whole times e to the power sigma square minus 1. So this minus is not in the power. Okay, so we can say the variance is mean square times e to the power sigma square minus 1, right? So this is all about standard normal, normal and log normal distribution. So let's stop here, and I'll see you in the next video. Thank you so much for watching.